Hi everyone, today we are going to talk about zero-knowledge proof technology. This topic is very popular now, so I decided to tell you about it. What is zero-knowledge proof? A zero-knowledge proof is a cryptographic protocol where one party, the prover, proves to another party, the verifier, that something is true without revealing how it's true. How many times have I said this phrase in my videos? This technology is used in such projects as Zcash and Aleo. By the way, if you haven't seen my video course about Aleo, you can watch it here. This technology was first proposed by scientists at the Massachusetts Institute of Technology in 1985. The article was called "The Knowledge Complexity of Interactive Proof Systems." So it's not a new technology, but it has only become realizable in our time. How does it work? Imagine that you are in a room with a person who is blindfolded. On the table in front of you there are two balls, a white one and a black one. You need to prove to the second person, the verifier, that the balls are really different colors without revealing which ones. To do this, you must ask him to hide both balls under the table. After that, ask him to take out only one so you can see it. Then the ball is hidden again, and the next time the verifier may again show either white or black. You will be able to prove the claim because you know exactly whether he changed them under the table. However, the verifier will not be completely sure in the truth of the fact because luck or cheating could have taken place. This problem is solved by repeating the experiment some number of times. With every round, the chance to be right by chance will halve. After 5 times, it will be 1 in 32. After 10 times, 1 in 1024. And after 20 times, about 1 in a million. Thanks to repeating, it's possible to achieve the desired level of proof reliability, but it's impossible to achieve absolute certainty. What is zero-knowledge proof used for? One obvious application of zero-knowledge proof in cryptocurrencies is to verify that a user has the funds for a transaction, without revealing to network participants who the user is and how much money they have in their account. By the way, if you want to programming using zero-knowledge proof, you can watch my videos about the Leo programming language. Leo is a programming language developed by the Aleo team. I made 5 tutorial videos on how to make programs using Leo and zero-knowledge proof technology. In one of the videos, we created a program that checks if a wallet has enough balance to make a transaction. Corporations collect a lot of information about each of us, personal data, habits and desires. Using this data, they sell ads and hold your attention more effectively. There is only one way out of this situation: delete accounts. There is no other way to keep your data private. But what if you want to take out a loan, for example? You are forced to give the bank accurate information about your income. Using zero-knowledge proof technology, you could give the bank information that your income is more than a certain amount. One condition is important: this range must be significant, otherwise it wouldn't make sense. Methods like this could help the financial world use blockchain technology. But it's difficult at the moment because of the lack of legislative ability to do so. What types of zero-knowledge proofs are there? There are 2 types of proofs: interactive and non-interactive. In the ball example, the interactive type of proof was used because the verifier himself interrogates the proving party in real time. This method has one major disadvantage, which is limited transferability. We proved to one person that the walls are different colors, but if we want to prove it to another person, we have to do it all over again. The other form is non-interactive proof. Using this option, we can provide a proof that everyone can check for themselves. As you know, on the Bitcoin network, all transactions are visible. In this way, it's possible to know how many coins each user has and where he spends his coins. At the very minimum, this is not safe. There are projects that use zero-knowledge non-interactive proofs to protect your transactions. For example, this is implemented in the Aleo project. No one will see how many coins and to whom you transferred. For blockchain, we have to use non-interactive proofs because proofs have to be verified by every node in the network. That is how blockchains reach consensus. It would be too time-consuming to prove our transactions to every node in the network. In addition to its many benefits, the technology has some disadvantages. First, the technology cannot 100% guarantee the correctness of the proof. We can only reduce the probability of mistake by increasing the number of checks. In this way, we can infinitely reduce the probability that someone will fake the proof. Secondly, the algorithm requires a large number of calculations, which creates additional difficulties. For example, previously it was impossible to run the algorithm on weak devices. Now the developers have made significant progress in solving this problem. Let's talk more about how this is implemented in crypto projects. We can do this with the example of my favorite project, Aleo. Aleo allows you to create private applications using zero-knowledge proof technology. You can go to aleo.org and see all the details of how the project works. I said earlier that zero-knowledge proof requires a lot of calculation. The developers have optimized this process, which allows to use this technology quite handy. The great advantage is that Aleo team created Aleo programming language and IDE called Aleo Studio, which makes the process of creating a private application as easy as possible. Let's talk about how zero-knowledge proof is realized in Aleo project. Until now, users have had to choose between the two, privacy or programmability. For example, Zcash gives users complete privacy by limited programmability. Ethereum provides powerful programmability but limited privacy. Aleo uses zero-knowledge cryptography to achieve both privacy and programmability. Like Zcash, this system gives as strong privacy guarantees as the transaction contains only the proof, not the inputs that generated it. And like Ethereum, Aleo can support smart contracts that enable users to interact or transfer value in a predefined way. How to transfer token using zero-knowledge proof technology? For this, we can use a decentralized exchange DEX. A DEX is a decentralized application that enables users to buy or sell tokens on-chain without needing to find a specific buyer or seller. For example, let's say you want to trade token A for token B on a Aleo-based DEX. First, you will need to prove to the DEX that you have enough of token A in your possession to complete the transaction. But because this information can be shown through a zero-knowledge proof, this doesn't mean revealing your wallet balance or trade history. Instead, you can reference an on-chain proof, a record, of a prior transaction to show that you have a sufficient balance to trade. When you make a trade on a DEX in Aleo, you compute the updated account balance off-chain based on the exchange rate. This trade is finalized by submitting a zero-knowledge proof as a transaction to the Aleo network, which indicates an action has occurred. The proof alone doesn't include any information about what the action was, on which exchange it was executed, or who was involved. Today I told you about zero-knowledge proof technology. If you like this video, please like it and subscribe to the channel. See you in the next video.